Hi class, in this video here I want to walk you through challenge exercise 6.2.2, and this is about relating confidence intervals to hypothesis testing, and there's three parts to this challenge exercise. So here's the first part. So an automaker is interested in information about how long transmissions last. Okay, so a sample of transmissions are run constantly and the number of miles before the transmission fails is recorded. Okay, great. So the automaker claims that the transmissions can run constantly for over 150,000 miles before failure. And the results of the sample are shown here. So you're given some Excel output and it has a lot of information here. And what you have to do is you have to answer all these questions based on this output. Okay, so the first thing here, it says, what is the p-value? So the hypothesis here is that it runs greater than 150,000 miles. So that's a one-tailed test right here. Okay, so you see that? So this is the p-value for that. It's 0.033. And then it says, what is the test statistic? Well, this is the test statistic where it says t-stat. It's 1.889. So it goes on to say, what condition is met for the use of the t-distribution? Do you see where it says observations of 44? So what you're seeing here is that the sample size is larger than 30 because there's 44 observations. So that works. Okay. So it says, what is the sample size? Well, that's that 44 I was talking about. What is the X bar? Well, that's the mean is 151.2. What is the degrees of freedom? And you'll look here where it says DF 43. That's your degrees of freedom. And now here's the thing. It's asking you, it says next, what is S? And that's the sample standard deviation. Well, they don't give you the standard deviation directly here, but notice how they give you the variance. So if you were to take the variance of 17.22 and square root it, this is the standard deviation. So it's 4.149 or so when it rounds, because you're going to go to three decimal places. It's 4.150. So let's check. Great, we got them. Perfect. All right, let's go and check out the next one, part 2 here. So it's the same problem here. Some of the things are going to change just a little bit in the numbers there. But again, the automaker is interested in information about how long transmissions last. So again, you're running the same thing. So the automaker claims that transmissions can run constantly for over 150,000 miles before failure, and the results of the sample are given here. Okay, so there's a lot going on here. Okay, so first off, it says, what is the level of significance? And you see down here where it says confidence interval of 95%. Well, that tells me the significance level is 0.05. What is the null hypothesis? Well, the null is always a statement of equality. And what we're looking to show evidence for of their claim is, no way, it definitely should be greater than 150,000 miles. So should H0 or the null be rejected, or does H0, H null fail to be rejected? In this case, you're going to reject it because if you look at your p-value of your one-tailed test here, it's less than the level of significance. Okay, so what conclusion can you make? It looks like there's a convincing evidence exists to conclude that the mean life of a transmission is over 150,000 miles. Okay, so that's good. All right, what is the mean life of a transmission then? Okay, well, it says, what is a 95% confidence interval? So if you look here, it gives you the mean, which is 150.7. And then if you subtract this down here is the confidence level margin of error right there. So you're going to subtract away 0.641, and you're going to get 150.059. Okay, and then you're going to do the same thing, except you're going to add. So it's 150.7 plus that margin of error. And you get 151.341. Okay. Does the confidence interval support the results of the hypothesis? Yes, it does. Okay. And why? Is it because the hypothesized mean, which is the null here, okay, falls outside the bounds of the confidence interval. Okay, because look, it says hypothesized mean is 150. Notice how that's just below here. Okay, so it's outside of this. Okay, so it means that that must not be true, which supports again our alternative. And we got them. Okay, let's quickly do this last one here. So a worker stands at the end of a production line for mint chocolate chip ice cream and uses warm water to melt the ice cream away from the chocolate. Okay, the amount of chocolate is then weighed. Okay, each container should contain 4 ounces of ice cream. It's a little bit of a typo here. It should say 4 ounces of chocolate. The result of a sample of 12 containers is shown below, and it says the amount of chocolate added to ice cream is normally distributed. Okay, so look here. Each container should contain 4 ounces, and it says the hypothesized mean is 4. So this is actually like a two-tailed test. We're seeing to see what the alternative is looking to see is that that it's not equal to 4. So what conditions are met for the t-distribution here? Well, notice there's only 12 containers, but it says the amount of chocolate is normally distributed. That's great. What is the level of significance? Well, it's 99% confidence, so it looks like level of significance is 0.01. Okay, so if you look here, look at your two-tailed test p-value. Okay, it's way greater than the level of significance. Okay, so what we're saying here is sufficient evidence does not exist to suggest the mean amount of chocolate in the ice cream is not 4 ounces. So even though the mean was a little bit less than 4 here from those 12 containers, it's just not enough evidence. So what is the confidence interval? So again, you're going to take your mean, 3.917, subtract away the confidence level for your lower bound, which gives me 3.734. And the upper bound is you're going to add. So you're going to take that mean and you're going to add. You get 4.1. And look, do you notice that 4 falls between this? So yes, the confidence interval does support the results. And why is this? The hypothesized mean here falls within the bounds. So that's why we're not going to reject. And we got them. So I hope it helped seeing me walk you through these challenge exercises for 6.2.2 from your Zybooks.